So students, let us begin today's lecture. Today's lecture will be on the chapter of quadratic equations, and the topic that we will cover is the topic of common roots. So what is the basic concept of the common root of two quadratic equations? Let's say we are given two quadratic equations, a1 x square plus b1 x plus c1 equals to 0 and a2 x square plus b2 x plus c2 equals to 0. Now we are supposed to find some relation between the coefficients, that is the terms involved in the two quadratic equations a1 b1 c1 and a2 b2 c2. So let's suppose that the root of the first equations are alpha beta and the roots of the second equation are alpha gamma. It means alpha is the common root. So using alpha as a common root, we are supposed to find some relation between a1 b1 c1 and a2 b2 c2. Let's see how we'll find that and what the relation will be. As we have said, alpha is common root of both equations. Therefore, it will satisfy both the equations. Whenever we have a root of a quadratic equation, it always satisfies the quadratic equation. So alpha is the root of both the equations, so it will satisfy both the equations. Therefore, what I will obtain is, in the first equation, when I put the value of alpha, I get the equation reduced to a1 alpha square plus b1 alpha plus c1 equals to 0, and the second equation gets reduced to a2 alpha square plus b2 alpha plus c2 equals to 0. So I get these two equations in alpha. Now from these two equations, we are supposed to eliminate alpha and thereby obtain a relation between a1 b1 c1 and a2 b2 c2, which will be our required relation. How we will eliminate alpha from these two equations? By using the method of cross multiplication. So eliminating alpha by using cross multiplication method. That is, I write alpha square by some value, which will be coming equal to alpha by some value, which will be further equal to 1 by some value. What those values will be? Let's write alpha square, and under alpha square I write the coefficients of alpha square from the two equations, which are a1 and a2. Then I write alpha. Under alpha I write the coefficients of alpha from the two equations, which are b1 and b2, and then I write 1, and under 1 I write the coefficients of the constant terms c1 and c2, and again I repeat alpha square, and under that a1 and a2, alpha and b1 and b2. Now what I will do is, under this alpha square term, I take the determinant of these two columns, that is the values under alpha and the values under 1. So I take the determinant, I calculate the determinant, it will be coming as b1 c2 minus b2 c1. Then further moving ahead, under alpha I will take the determinant of the next two columns, that is the values under 1 and again the values under alpha square. So that will be coming as c1 into a2 minus c2 into a1. So c1 into a2 minus c2 into a1, and under 1 I will take the determinant of the last columns. The last columns we can see clearly the values under alpha square and the values under alpha. So that will become a1 into b2 minus a2 into b1. So cross multiplication method students have already learned in their previous classes. So I am just demonstrating in another way by using the concept of these determinants. So we get these values under alpha square, under alpha and under 1. Now we will compare the two equations at a time, that is I compare the first and the second. Alpha square divided by b1 c2 minus b2 c1 equals to alpha by c1 a2 minus c2 a1, and then later on I will take the third equation and second equation, that is alpha by c1 a2 minus c2 a1 equals to 1 by a1 b2 minus a2 b1, and simplify the terms. So let's see what that will become. So from the first and second equation I get alpha equals to B1 into C2 minus B2 into C1 divided by C1 into A2 minus C2 into A1. From the second and third equation I get alpha equals to C1 into A2 minus C2 into A1 divided by A1 into B2 minus A2 into B1. Now comparing both these values of alpha, we get B1 into C2 minus B2 into C1 divided by C1 into A2 minus C2 into A1 equals C1 into A2 minus C2 into A1 by A1 into B2 minus A2 into B1. On simplifying the terms, finally we obtain A1 into B2 minus A2 into B1 multiplied with B1 into C2 minus B2 into C1 equals to C1 into A2 minus C2 into A1 whole square. So this will be our final result, the required relation, which is the required relation between the coefficients A1, B1, C1 and A2, B2, C2. So whenever in any question two quadratic equations are given and the condition is given that they have one root common, then we are supposed to apply this result. We will directly apply this result and solve the problems. So now the thing is, this result seems to be a little difficult to remember, but it is not at all as difficult as it looks. Let's understand how we will remember this result and then apply on our questions. What I do is I write AB minus AB, then BC minus BC equals CA minus CA whole square. That is, I have written these terms by considering a cyclic order of ABC, AB, then BC and then CA. So I multiply AB minus AB into BC minus BC equals CA minus CA and put a square on the right side term. Now what I do is I put up the subscripts, that is A1 into B2 1 2 2 1 1 2 2 1 1 2 2 1. That's it. A1 into B2 minus A2 into B1 1 2 2 1, B1 into C2 minus B2 into C1 1 2 2 1, C1 into A2 minus C2 into A1 whole square. So the result is completed. So whenever we come across questions, we will just write this result, put up the values of A1, B1, C1 and A2, B2, C2 and thereby solve it. So this is the final result that we have. Now let us just see some illustrations using this result, using this concept. So here we come across the first question, which is we are given two equations, x square minus 5x plus 6 equals to 0 and 2x square minus 3x plus k equals to 0, and they have one root common. We are supposed to find the value of k. Let's see the options as well. We have been given the options as minus 2 minus 9, 2 9, minus 3 6, 5 and minus 8. So we will solve this question using the result that we have learned just now by applying it directly. Let's see. So we are given the first equation as x square minus 5x plus 6 equals to 0 and the second equation as 2x square minus 3x plus k equals to 0. If we compare these two equations with the standard form of the quadratic equations, we get A1 as 1, B1 as minus 5, C1 as 6 and A2 as 2, B2 as minus 3 and C2 as k. So now applying that result, what that result is, let's write it again. AB minus AB into BC minus BC equals CA minus CA whole square. Then I write 1 2 2 1, 1 2 2 1, 1 2 2 1 as subscripts in all the terms in the same order. So here I will just put the values of these terms, that is A1, B1, C1 and A2, B2, C2, and we shall be able to obtain an equation in K, and simplifying that we will be able to get value of K. Let's see. So I put the values, that is A1 into B2, it comes out to be minus 3. I am directly multiplying from here. then minus of A2 into B1, that is 2 into minus 5, it will be minus 10. Then B1 into C2 will be minus 5k, and B2 into C1 will be minus 3 into 6, that is minus 18, equals C1 into A2, that is 12, minus C2 into A1, that is k whole square. Let's simplify the terms a little bit. It becomes 7, it becomes 18 minus 5k equals 12 minus k whole square. So we get a quadratic equation in k. Let's simplify this equation. So the equation in k reduces to k square plus 11k plus 18 equals to 0. Now this is a quadratic equation in k which can be solved using factorization method or formula of roots. Solving for k, we will obtain k as minus 2 and minus 9, which will be our required values of k. So we solve this question by simply applying that concept, that formula, that relation of the coefficients, that is a1 b1 c1 and a2 b2 c2. The same question can be solved in yet another way. Let's see that as well. So alternatively, we were given the two equations as x square minus 5x plus 6 equal to 0 and 2x square minus 3x plus k equal to 0, and we have said that they have one root common. In the question, the condition was given that they have one root common. What we can do is we can find the roots of the first equation and thereby use them in the second equation. That is, I solve the first equation, x square minus 5x plus 6 equals to 0, and I get the values of x as 2 and 3. Now these values of x will also be the values of the second equation, as the two equations have one root common. So we take here two cases. What that cases will be? Case 1 is 2 is the common root. 2 is the common root. Therefore 2 will satisfy the second equation, that is 2x square minus 3x plus k equals to 0. So I put the value of 2 in the second equation, that is I replace x by 2. So it becomes 2 into 2 square minus 3 into 2 plus k equals to 0. Solving for k, we get k equal to minus 2. Similarly, so case 2 will be 3 is the common root. Therefore 3 will satisfy the second equation also. So in the second equation I replace x by 3, 2 into 3 square minus 3 into 3 plus k equals to 0. Simplifying, we get k equals to minus 9. So therefore k is coming minus 9 from the second case. So from the first case we had obtained k as minus 2, and from the second case we had obtained k as minus 9. So the second method, the alternate method, by using the concept of the common root means it will satisfy both the equations. So let's see the options. So we were given these options. So clearly we can see here the first option A is correct and the options B, C and D are wrong. So A is our correct answer. So let's see some more questions on this topic. I am given two equations, px square plus qx plus r equals to 0 and qx square plus rx plus p equals to 0 under the conditions p should not be 0 and q not equal to r, and they have one root in common. What we are supposed to find is value of p cube plus q cube plus r cube. Let's see the options. So option 1 is minus 3 pqr, option 2 is 3 pqr, then p plus q plus r, and lastly minus of p plus q plus r. So we will solve this question as well by using the concept of one root common. Let's see that. We are given the two quadratic equations as px square plus qx plus r equal to 0 and qx square plus rx plus p equals to 0. If we compare these two quadratic equations with the standard form of quadratic equations, we get a1 equal to p, b1 equal to q, c1 equal to r, then a2 equal to q, b2 equal to r and c2 equal to p. Now applying the concept of the common root, I write that formula again. AB minus AB into BC minus BC equals CA minus CA whole square, and then we use the subscripts 1 2 2 1, 1 2 2 1, 1 2 2 1. Let's put the values of all these terms. We get A1 into B2, it is PR, minus A2 into B1, it will become Q square, B1 into C2 will become PQ, and B2 into C1 becomes R square, equals C1 into A2 becomes QR, minus C2 into A1 becomes P square whole square. Let's simplify the terms. So I simplify the terms, they become P square QR minus PR cube minus PQ cube Q square R square equals Q square R square plus P4 minus 2P square QR. On simplifying, let's find out what it becomes. So on simplifying, we will get P4 PR cube PQ cube minus 3P square QR equals to 0. I take P common. So P into P cube plus R cube plus Q cube minus 3PQR equals to 0. We get two factors, either P equal to 0 or the second factor, which is P cube Q cube R cube minus 3PQR 0. As we were given the condition P is not 0, therefore we are left with only this condition, PQ Q cube plus R cube minus 3PQR equals to 0, which gives us P cube plus Q cube plus R cube equal to 3PQR, which is a required relation. Let's go back to the options. So we can clearly see B option is the correct answer. A, C and D are wrong answer. So we get B answer as the correct answer. P cube plus Q cube plus R cube equals 3PQR. So in this question again we applied that formula, the relation between the coefficients, and thereby putting the values of PQR we obtained an equation in PQR, and simplifying we arrived at a result. Let's see some more questions. So the next question I take is, again we are given two equations, Px square plus Qx plus R equals to 0 and Rx square plus Qx plus P equals to 0, where again P is not 0, Q not equal to R, have one root common, and again we are supposed to find some relation between PQR. We are getting the options, various terms in PQR in various options, in all the four options. So this question again we will solve by using the same concept. Let's see how. So we are given the equations as Px square Qx plus R equals to 0 and Rx square plus Qx plus P equal to 0. Let's compare again with the two quadratics and obtain the terms A1 B1 C1, A2 B2 C2. We get A1 as P, B1 as Q, C1 as R, then A2 as R, B2 as Q again, and C2 as P. So let's apply a result, AB minus AB into BC minus BC equals CA minus CA whole square, then 1 2 2 1, 1 2 2 1, 1 2 2 1. Let's put the values and simplify. So A1 B2, A1 B2 will become PQ minus A2 B1, A2 B1 becomes QR, then B1 into C2 becomes again PQ minus B2 into C1 again becomes QR equals C1 into A2, it is R square minus C2 into A1, that is P square whole square. That is what we obtain is PQ minus QR whole square equals P square minus R square. I rewrite the terms on the right side as P square minus R square whole square. Or what we can do here is we will obtain Q as common, it becomes Q square into P minus R whole square equals P minus R whole square into P plus R whole square. P square minus R square I factorize as P plus R into P minus R, and let's now further simplify it. I bring all the terms to right side and I will find that I will get Q square common, and we will be left with r minus p whole square minus of r plus p whole square into r minus p whole square equals to 0. And I can see here clearly r minus p whole square is coming common. I am left with q square minus r plus p whole square equals to 0. Now this is further reduced as q plus r plus p into q minus r minus p equals to 0. As we were given r is not equal to p, therefore we are left with these two factors, q plus r plus p into q minus r minus p equals to 0, which gives us p plus q plus r equals to 0, and second result we will have q minus r minus p equals to 0, which can be further simplified as p minus q plus r equals to 0. So therefore we get these two results, p plus q plus r equals to 0 and p minus q plus r equals to 0. Let's see our options. So the first option is p minus q minus r equals to 0, which is not correct, and the second is p plus q minus r equals to 0, which is also wrong. Third option we had obtained one result as p plus q plus r equals to 0, which is absolutely correct, and the fourth option also we had obtained the second result as p minus q plus r equals to 0, which is also correct. So both the options C and D are correct. So C and D are correct answers. Now this is a question of previous year's IIT advanced paper, that is JEE advanced. So here also we just applied the concept of the common root, we just use the formula and thereby arrived at our answer. So in this topic, whatever questions, whatever concept that we have discussed, if you have any doubts in all the concepts, in all the illustrations, in all the examples, you can discuss it. Thank you so much.